So now in my last video, we took this A-stable mode 555 timer right there to switch an NPN bipolar junction transistor, which has a load that is an LED right there. The load is being protected for 5 volts right there. We're getting 5 volts across the load, 220 ohm resistor. So we're going to change the voltage. My goal is to light this LED module right there, which is a much higher power module than the load we got there. The transistor that I have on the board right now actually might be okay, but probably should not use that one. So first thing I'm going to do, might as well turn the power off, remove this load right there, because we're going to need a higher voltage. This is the LED module right there. Now an interesting thing, this is I believe rated for like 12 to 24 volts, and I put like 30 on it, and I think we were okay with 30. They didn't like give a voltage range. I think it's for like 12 or 24 volt batteries, which actually do get close to like 30 volts when they're fully charged. Okay, so yeah, I got the alligator clips there. If I short circuit, this will just turn off. But yeah, I already did a little bit of testing on this, and so instead of the usual 20 milliamps max, I got 220 milliamps, which is the same as 0.022 amps. So turning the power on, 5 volts is not enough to power this module, and we're gonna see, there we go, bright light. That is not how much current this actually uses. We just don't have enough voltage right now. Bump it up to 10. There you can see 1.6. So I'm thinking this is probably the minimum voltage you should use with this module. It obviously has a buck converter in there, which takes the higher voltage we're giving it and applies the lower voltage to the LEDs. Because you can see the conversion. As we raise the voltage, the current goes down. And so for the 555 timer, since I'm using it in this video, I just looked at the data sheet, and it says there's an absolute maximum of 18 volts. So I'm guessing to stay in a really safe range, probably 12 volts is where we should limit the voltage we apply to the 555 timer. I'm going to swap the transistors coming up, but I believe these can operate up to like 30 volts. So I'm not even going to look that up right now. But yeah, 555, I definitely saw like 18. So I think that's kind of the weak component that we're going to have for this circuit. So that's something to keep in mind. Now, we have the, I'll turn the power off. We have the LED module here that we're going to power. As we saw, at like 10 volts is like 160 milliamps of current that we needed. That was pretty much all, or yeah, that was all going through this module. That was the only thing I had wired up at the time. I'm going to add it to this circuit though. This is the 2N3904 because I used it in the last video where we had this circuit. But I just want to quickly modify this circuit to be able to light that LED instead. So, especially at 12 volts, I think we'll be fine with this one, but we're really pushing its limits. It has a maximum of 200 milliamps of current, if I remember right. And it may be modified so that, you know, if there's extra letters at the end or something, maybe like slightly improved, but I'm pretty sure we have a 200 milliamp current limit. Same with the 555, by the way. So, this is a 2N2222. I don't have my loop on me right now. I'll make sure and look to double check. Yeah, I can see 2N2222. And they can switch up to 600 milliamps of current. I believe the improved ones may be even 800. But in any case, you should still stay about halfway below the maximum. Now, I'm pretty sure I'm going to have to change the resistor. The output's going to provide a little bit of current. That's 10,000 ohms. I'm pretty sure that's too low, but for this prototype circuit, I'm going to see how well it does. And then we'll move this there. So there is a space I could grab. It would look better. A fixed jumper, or not a fixed jumper, think you would call that a cable, whereas this is a jumper wire. The cable would be a little bit neater. Make sure I'm putting it in the right spot right there. And we will go to the positive supply. So I already have the power supply set to 12 volts. Plenty to light this, and I will go there. So yeah, this is not something I did before. I'm just kind of going with the flow here, but that's how easy it is to modify circuits for certain changes, as long as you are aware of the electrical limitations of stuff. So yeah, I'm pretty sure we are squared away. Maybe something will fry or whatnot, but yeah, that's why we have that limit. But yeah, that is literally about all I had to do. And there you can see we have burst where we got kind of high current. Maybe that is, I'll pluck this. But yeah, there. So the I'm not sure exactly how much is all the light. Probably exactly what we saw with the 12 volts right there. So looks like there's a fair amount of current, probably like elsewhere or something. But no components are currently fried. So now I'm pretty sure I figured out what was the problem with the high amount of current that we have. As we saw before, when this module doesn't have as much current across it, when it had 10 volts across it instead of 12, that's when it needed the most current. I can, hopefully this isn't too hot. Now, this will look different. I didn't change the circuit. I just shuffled things around so that they were not as, you know, cluttered. But there you can see, this is all that we are asking of the circuit right now without the LED module. So when it's on, we should be getting basically the current that you see on there. This adds just a tiny bit to it, just makes it slightly higher. And so the current that we see on the power supply is basically the module, just a spec higher due to the other circuitry. And so we saw at 12 volts, and oh, the clip came off right there. If you got a problem with your circuit, always measure the voltage that is powering everything. And if you don't see any, then you know that the reason why is because you accidentally disconnected the power. So yeah, this is why I needed space. I want to try to go to just wherever there's a direct connection across the module. And there you can see it's going too fast. I wasn't thinking ahead here. Now we could use an oscilloscope to measure this. In the earlier video, I increased the timing 5 times by using a capacitor that was 5 times larger. And I was able to measure with, this is a auto ranging, but it takes a little bit of time to get the ranging set. And so I just used a manual setting multimeter to measure. And there you can see, I said earlier that I think there's probably like 10 volts across here. It's slightly less, but again, the less voltage across it, the more current it's going to need. But at 9 volts, I think it just didn't have enough voltage to quite get all the power delivered to it. Remember, like 8, was it like 8 or something? It did like produce light, but hardly any current was flowing. You know, you need enough voltage to get the full current flowing. So my theory is that we don't have enough current coming from the 555 timer to turn the transistor on fully. We just saw we got like 10 volts across there, and this is going on longer than it should. You can see we got the rest of the supply voltage across here. Plus there might be like some other losses. But you add up the voltage across the transistor while it's on and the load there, and basically you get the supply voltage. So we want to lower that voltage across the transistor so that it fully goes across the lights. Also, this is a fair amount of current. The more voltage we have across the transistor, the hotter it's going to get. So to keep it from getting hot, we want to get the voltage as close to 0 as possible. So now we are back. I have a solution. I actually shot this scene but deleted because I made a fatal mistake. This is a 10K resistor. I want a 1.5K resistor. The colors really turned out bad on the color code there. And I just quickly grabbed a package. It was like 15K. I didn't actually realize that. I was getting basically the same result as the 10K. But when I looked at the color code of it, I saw a red band on what I thought was a 1.5K. but that red band tells me, you know, there's a red band on the 10K that were in the tens of thousands, 1.5. So that's how I quickly realized I grabbed the wrong package. I want 1.5K right there. So yeah, you don't have to master the color code. I've done color code videos, just simple ones. But being familiar with it helps a lot. So I'm going to turn the power on again. We have that 10K. I meant to have the capacitor on there, but since we don't see a flash, obviously that was indication that I moved the capacitor. I stuck it to the wrong spot. You should not be wiring stuff while it's live. But again, I'm trying to not edit more than I have to. But yeah, there you can see. You know, it looks like we're getting up to about almost like 200 milliamps of current. So I am going to turn the power off when I swap the resistors. And so this should not be too hot. Not much current was going through there. And so the 1.5K though, since we have 12 volts, I could probably use 1,000, especially because the 555 timer falls a little bit short of the full supply voltage. So 1,000 would probably be perfectly fine. But I figured I'd add a little bit of safety. As I said before, don't try to push components to their limits. So now I suspect that and oddly enough, I think when things were cooled down, I needed less current. But in any case, I'm going to turn the power on because I was a little suspicious. It was like low when I started, but then I noticed the current rose when I had the wrong one. So again, while it's flashing, we're not going to get as accurate of a reading. So when the light's on, I'm going to yank it, and there you can see. Actually, it's not as low as I expected right there. 1.49, but I think it is a little bit lower. So let's check the voltages. I'm thinking that you know, we have enough voltage. It may need to be improved even more, it looks like, but I think we'll be fine with this setup. But yeah, there you can actually see about the full voltage across there. You know, it's not going to get the complete supply voltage. If we got a little bit more base current, it would probably do better. But in any case, it's not too bad. We got about 0.127 out of the 12 volts. It's going to be a little less again because we got like a little bit of resistance and stuff. That's why sometimes you'll see the supply voltage is slightly higher. You know, like if it's 5 volts, it might be like 5.1 volts instead of 5. That's because you get a little losses along the way and stuff. So if the load absolutely needs 5 volts, you want to be a little bit higher. But yeah, that I think proves our point. Let's look at the voltage at the output right there. So I'm going to go to the ground terminal, and then hopefully I don't short anything right there. That could cause problems. But yeah, we got about 10 volts coming out. We're losing a little more than 2 volts because we're providing a fairly significant amount of current. You know, not like a lot of current, but enough to make it so the voltage doesn't go to the full supply. It never does with the 555, but it gets worse the more current that you have to provide. But yeah, in any case, that was really it. If I wasn't making a video and explaining things, I could probably have modified this from flashing in LED if I had like the components already on the board, which I basically did. You know, I could swap this from flashing in LED to flashing a higher wattage LED, and you know, maybe less than a minute or something. It's that quick to modify. So when you're learning the circuits, it's not so much that circuit's going to be great for you one day. It's that you can take that circuit and quickly modify it to do what you want. In this case, to power a higher load. It was that simple. If I wanted a flashing, I could flash this just like I did with the LED, just with a few modifications that we saw there. Lower output resistor is a good idea right there, and a transistor that can handle more current was a good idea, even though the lower power handling one probably wasn't going to be fatal, but we were really pushing the current, especially at like 10 volts. So probably real good idea to swap those transistors. But yeah, any case, hope you enjoyed. Thanks for watching. I'm going to turn this off. Make sure to turn the meter off. Thanks for watching. Make sure you check out the links down below. They all help out a lot. And I'll see ya in the next video.